All right, it's time for some science. This episode, we're going crazy on the science department, and we're going to push the limits of a super high-end 3D printing technology from Markforged in this episode. Now, I'm not going to go into a ton of the science and stuff in here, just for the simple fact that this is a fishing channel, right? This is not a science channel, but
You know, I'm something of a scientist myself.
we're going to design a crappie bait. We're going to talk about how I'm going to 3D print it using Markforged technology and using their onyx material. And then we're going to try to, heat some plasticol up and pour it into that mold that you see sitting right back there. But look at that. Look at that bench, man. I've been pouring a lot of baits because of a show lately. And we can't work with that. So I am going to spend some time here cleaning this thing up, and through the magic of editing, you guys are not going to have to watch that. Much better. Now, let's dive into the meat and potatoes of this video. Now, I teach 2 and 3D design, CAD and CAM in my actual job as a high school teacher to teach guitar building. So I thought, what better way to show a use case for the stuff that I'm teaching my kids as far as CAD and CAM and basically designing for additive manufacturing as well with 3D printing than to try to do a real world project. Well, I had an idea to try to create a crappie bait because I want to do a catch cook series for you guys here on another line over this summer. I'm going to do a lot of it because I plan on eating a lot of fish this summer. I am right now trying to take part of the carnivore diet. I'm about 5 weeks into that right now, and I've dropped like 13 pounds. So I feel good. I don't know if this is going to be something that I'm going to be able to sustain the rest of my life or even the rest of the summer. But for right now, I'm diving into that, and I want to be able to. I eat a lot of fish anyway, but I don't show you guys the fish that I eat. This video is going to be kind of dedicated to creating a crappie bait, 3D printing the mold, pouring the plastisol, and then hopefully in the next video of the series here, you'll be able to see me going out with this bait that I'm getting ready to make in just a second to catch a crappie. Now, is that going to work? I don't know. So first off, let's dive in here a little closer and let's look at the mold that I made, and then we'll talk about the process that it took to get to where we're at right now. I didn't want to bore you guys to death with the 3D printing and all that stuff because that's probably not why you're here. You like to fish, and that's why we're here on this channel. So I don't want to bore you to death with the science of that. But I'm going to bring you in a little closer here onto the workbench. We're going to look at what I have. We're going to look at, and then a little bit later in the video, I'm going to show you a time lapse of me designing it and looking at it in the Markforged Eiger software. And then we're actually going to pour this bait today and see if it works. Now, you guys are going to see this video no matter if it works or not. Disclaimer. Markforged has nothing to do with this. This is Markforged, first off, is a really high-end additive manufacturing company that deals with some of the world's highest end 3D printers. This is not a how-to. This is also not, hey, you probably have this in your garage, because you do not. And I am also going to be pushing the limits of the onyx material that we're going to be using here in this, which is it's a proprietary chopped carbon fiber and nylon based material that Markforged uses in most of their printers. I printed this on an X7, again, way above the scope of what you guys are going to have in your garage. But so we're going to check this out, and we're going to, try to get into a little science today. Hopefully this works. Again, we're pushing the limits of what this material can handle. But if all goes well, we should have a crappie bait that we can go out and try to catch one with. What I have right here is the mold that I've designed and 3D printed. Again, this is a material called onyx from Markforged. This thing right here, the cool thing about Markforged technology is that this thing is super high end. I made this circle right here 5/8 of an inch because that's what the standard extruder nozzle is, and it is uber exact. It's almost a press fit. That is crazy. Now, let's open this thing up a little bit. Let's look at this. So, you can see here that I've created this mold in 2 parts. There's a lot of stuff in this mold that would not happen in standard subtractive manufacturing. You can see here in this, there is a fin at the top of this. So this is would be the top of the bait. So you're looking at the top here, but it's upside down. And then on the edges here, probably gonna be tough for you guys to see, but there's an undercut there. It's a fin that's kind of like at an angle that I designed that way. You're not gonna be able to do this with standard subtractive manufacturing like CNC and stuff. Now that's the reason I chose to do it this way. But this mold didn't just happen to be like this. Another cool thing, made these little standouts here. Look at this. So satisfying. So good, man. I'm telling you what. But anyway, this mold didn't just happen to be like this. So I designed it this way. So here's a short time lapse of me designing this bait. Again, don't want to bore you guys to death because you're here to catch fish and not worry about designing baits, but using this for a use case for my students. So here is a time lapse of the design and looking at it in the Eiger, and then we'll get back into pouring the baits. All right, apologize. I got half my head cut off here, but down here is what we're looking for. Got the mold. You guys just saw how that was made. Again, this is not a run-of-the-mill 3D printer. You're not going to have this in your basement. Probably not. I'm lucky enough to teach my students some really high-end stuff. So that's where this comes from. Made out of onyx material. We'll talk about that in just a second. I got a cobalt. This is just a thermometer to show the temperature of the plasticol, because we'll talk about that in just a second. That's going to be a necessity. I am going to, first off, this thing must be not on there good. Got glitter everywhere. This is going to think I've been the strip club. Anyway, I'm just going to use holographic silver flake in here. I think if I put enough flake in this plasticol, then I won't have to use any colorant. The reason that is because I don't have a colorant that's bait fish shaped or bait fished collared. I got green pumpkin. I got green pumpkin green. I have pumpkin seed. I have green pumpkin. I'm sorry, I have watermelon green. I have a lot of different stuff including fluorescent green, but none of these are going to be bait fish. Again, this is going to be a crappie bait. Could you get by with using one of these other things? Sure you could. It's going to need a really handy dandy butter knife as a stir component, a couple of gloves because this stuff gets really hot. I have a Pyrex container here, something that is microwave safe. Microwave's back here. And then I have some plasticol from Do It Molds. So this is where it gets kind of scientific. And the thing about Onyx is that I told you guys in the beginning of the video, we're going to be pushing the limits of this material. And again, this is a disclaimer. This has nothing to do with Mark Forge or the Onyx technology. I'm going to be pushing this stuff to the limits. The deal is that this has a heat deflection temperature of just a little over 300 degrees Fahrenheit. It's like 307 degrees Fahrenheit. And what does that mean? Well, science, right? But if you were to heat this up and push or put pressure on this, it would deflect, it would bend, it would melt. It really doesn't melt, but it just deforms. Now, the problem with that is the fact that you're going to be pushing this in here, and I'm going to be pushing plasticol, which is going to be, it's a fluid. So we're going to have some some hydraulic pressure in here, which is going to cause this thing to either want to come apart or kind of deform on itself. So we're going to try to get away from that by clamping this together, but we're going to just put enough pressure in this thing to fill the mold up, and hopefully it doesn't deform. Again, this mold is high-tech for what it is, not designed to do this technique with it. So what I'm going to do right now is I am going to get this thing all clamped up. I am then going to put some plasticol in the microwave. Now, why is this thing here? Well, because it takes like 320 to 350 degrees to get this plasticol crystal clear and melted, and basically getting ready for the transformation that happens between this to like I have something here. So this is just a sprue from an old pour. So this started out as clear plasticol, but has been through the thermal process to make it what we're looking for. So with that being said, I'm going to throw some plasticol here into the microwave. Not going to bore you to death with that. Get this thing all clamped up, then we'll be right back. I'm not going to mix up a ton of this stuff because that mold's not going to hold a bunch of material. And we're just going to be reusing it. That's probably way too much, but I want to make sure that it's all getting good and hot. So I'm going to put this in the microwave, bring it back out. You'll see that it's clear, kind of milky now. It's what it's supposed to look like. Once it gets hot enough, it goes clear. I'm going to put a lot of that hollow silver, which is 0.015 from Do It Molds. And then I'm going to make this thing hopefully look white and silver just with that little bit of flake. Again, we're going to get this thing down to right at 300 degrees, which is just below the heat deflection point of this onyx material. And we're just going to, we're going to go with it. Again, while this thing's heating up, I think plasticol has to get up to like 350 degrees Fahrenheit roughly to have that chemical reaction happen. So if you're not getting it hot enough, it's not going to go clear, and it won't have the process. It won't go through the thermal process to make it clear and basically bait shaped. It'll be just liquid at that point. It'll turn into a solid if you get hot enough after a while. Now, it's one of the things we kind of have to deal with here is with this mold. Normally, molds are made out of aluminum. This is a Do It Molds 4-inch stick bait Cinco mold made out of aluminum. I don't know what this is, probably like 6061 aluminum or something. Has a really nice hinge back there, but this aluminum stays cold, right? It's cold out here in the garage. I have the heater going on, but it's not super warm. It's like 40 degrees here in Ohio. I was trying to go fishing yesterday and all the lakes were frozen, so which is a first for me. But The deal is with this is not going to dissipate that heat very quickly. So when I actually pour this or when I inject this, I'm going to give it a good 5 to 7 minutes to naturally cool down before I pull it out of there. One, because I want the mold to cool down, but two, it's not going to dissipate that heat like an aluminum mold would. So it's going to take a little bit longer. Again, this is not a mass-produced bait here. If I was going to make, millions of these things, I would make it out of aluminum. But the thing about it is, I don't have the ability yet, I assume we'll have, to make the subtractive manufacturing molds like this. So I chose to see if I could do it with additive manufacturing. And again, it may or may not work. You guys are going to see an epic success or an epic failure here in just a short amount of time. All right, out of the... It's 376 degrees, which way too hot. I may have actually burnt this batch. You normally do 4 minutes on a full 2 cup. This is 1 cup, so it's 340-ish degrees. So it's going to take a little bit to cool down, but I'm going to go ahead and start adding some of this flake, and I am going to add a lot of it. I'm going to stir it up, see what's up. Again, I'm trying to make a colorantless bait that looks like a bait fish. If you guys can see that in there very well. Again, I don't know. I'm leery about using this little bit of plasticol because it got uber hot. It almost looks burnt. So I guess we're gonna shoot it because I don't want to waste the material. That little bit of brown color may actually help my bait look more bait fish like. I am going to add a little bit more of this 0.015 hex hollow silver flake. Again, I'm not putting any colorant in this bait at all. It's just going to be straight flake. And I've never tried this, so it may be a failure all the way around, but we got to start somewhere. We'll give it there, see where we're at now. There, we're looking at 304 degrees Fahrenheit. So it needs to come down a little bit more. All right, 300 there. So now all the work, all of the stuff that's came into this situation, all comes down to this right here. So what I don't want to do is I don't want to blow the side of this mold out. So I'm going to go very slowly. Feels like it's full there. I'm going to fill the sprue up a little bit here so it has some retraction ability. Well, that was no bueno. So anyway, start the clock. 7 to 10 minutes later, we're going to demold it and see what happens. So far, it looks like it all held together. Does it work? See you in about 10 minutes. All right, took the dog out. Been about 10 minutes or so. So now it's time for the proofs in the pudding, folks. It's either going to work or it's not. I'm feeling some heat coming through the mold, but it's not astronomical. Maybe it did dissipate some heat. Should be able to see in that sprue right there. See how much that plasticol shrinks when it gets cooler. So that's why you fill that sprue up. And I designed this bait mold to have a really thick sprue line in here to keep that. Now, one thing I'm really worried about in this bait is, and you saw in the design process, I made those little tail sections very, very tiny. So I'm actually kind of scared to open this thing up. It a little stuck. It's all right. Should have probably used some mold release, but uh-oh. So it came loose here. I'm gonna go very easy. This is, you can see those tail sections there. This side kind of stuck, so I'll grab something here, see if I can't get those things unstuck. I definitely don't want to rip those off. Again, that was the one thing that I was really worried about, and I think after the first couple pours of this mold, it will kind of work itself out. Still kind of very tacky. I don't want to just rip it out of here. Oh, dude. Some of the tails didn't come out as well as I'd hoped. Some of them didn't go through at all. But look at that thing. So this is the one that I was hoping that wouldn't stick. I should have probably made vent holes so some air could get out of here. I was thinking that this additive manufacturing process or 3D mold would let air get through there, but where I'm using this Markforged technology, it's probably a lot more precise than your, I know it is, it's a lot more precise than your run-of-the-mill FDM printers. So this, can't tell if it's still kind of warm. I don't know if I want to like all one fell swoop pull this sprue up out of here. I guess you only live one time, right? I just don't want it to break. This fin is at an angle like this, like it's not parallel. I want it to have some movement in the water, so I'm going to demold this thing. I'm going to see what the best way to demold this thing is. Once I get it done, I'll show you the bait, but I'm going to pour a couple more. It looks like, again, the tails are not going to work due to there's no release of air. Maybe I just won't clamp it as tight next time. So I'm going to demold this thing, show you bait what it looks like. So this plastisol is actually a little more robust than I thought. Still kind of crazy. Rip one of these things off here so you guys can see the bait. I'll show you guys more pictures of it. Up close pictures, obviously. But look at that thing. It's got a really cool fin on top. Some like fins that are, they definitely don't look at you. They kind of slant up. So I'm hoping, I mean, look at that tail. Look at that tail, boys and girls. What am I? Choo-wee, look at that thing. That's awesome. Oh, it's getting a little bit of heat build up in it. This is the second pour. I don't want to press my luck and keep shooting in this mold because as the mold keeps getting hotter, the deflection temperature is just going to keep getting lower and lower due to the fact that it's going to be retaining some heat. Got a little flashing around the tails of this one, but that is good. That means that the tails have shot all the way through. I'll show you in a second. Yeah, got some flashing around some of them, but that's all right. That one right there came out Perfect. Holy crap. Some of the tails didn't shoot as far as the little ball. So I made this little ball here on the end of these tails 1/8 of an inch. You can see right there, there's an absolute perfect one. That flashing right there will just pour off or pull off, but I kind of like that, at least on one of them. That means that the air has escaped, which is probably why these tails poured. And I love that color too. It's really bright in this light, but it's really not that bright. I'm going to pour one more because why not? But that's going to do it here, guys, for this video. Pretty daggone crazy that you can take some science and bring it into the fishing world. Now, baits like this, again, I showed you here, I'll show you exactly what I'm talking about up close in a picture here. But this couldn't be made with subtractive manufacturing, with like taking an aluminum block and making it like this, because of the undercuts that the fin has. It had to be supported in the design for additive manufacturing in the Eiger software. But I'll tell you what, guys, anytime that you can take some science, put it together with something you love, it is a good day. So if you like this video, make sure you hit that subscribe button. We're going to go out and try to catch some crappie with this thing, do a catch cook, and we're going to throw down on some Hunt Chef products this year. They're great, great, great seasonings, and they're made for you and me. They're made for outdoors men and women, and they're basically, it's called cook what you kill, or cook what you kill. So that's the deal. We're going to be using some real damn deal seasoning on some crappie in the next video, because we're going to go out and catch them with the Crappie Rocket 1.0.